The femur is an absolute powerhouse. It's the longest, the heaviest, and by far the strongest bone in the entire human body. It takes a massive amount of force to break it. But what happens when the force is so extreme that it doesn't just break, it shatters in two different places at the exact same time? Well, that's not just a bad day. It's one of the most complex and high-stakes challenges in all of orthopedic surgery. So that's the big question we're diving into. How in the world do surgeons piece together the body's strongest bone when it's been fractured into three separate pieces? As we're about to find out, the answer is, well, it's anything but straightforward. What you're looking at right here is something called an ipsilateral femur fracture. Now, ipsilateral is just a fancy way of saying on the same side. This kind of double break is pretty rare, and it's almost always the result of some kind of massive trauma, like a really bad car crash. Now, the problem with this injury isn't just how severe it is, it's also incredibly sneaky. Before a surgeon can even start planning the repair, they have to be 100% sure they've actually found both breaks. And that, right there, is where the diagnostic trap is set. And here's the trap. The main break, the one in the middle of the thigh bone, is usually super obvious. It's displaced, it hurts, you can't miss it. But the second break, way up near the hip, it's often subtle, what we call non-displaced, meaning the bone pieces haven't really shifted. It's so easy to overlook that, and up to a third of all cases, it gets missed completely on the first x-rays. And that can lead to some truly devastating problems down the line. Okay, so just to be totally clear, let's recap. We are talking about one bone, the femur, with two separate fractures. One break is on the long shaft, and the other is way up high on the neck, close to the hip joint. Look, fixing either one of these is a major surgery. Fixing both at the same time, that is a real puzzle. And that puzzle has sparked a pretty fundamental debate inside the world of orthopedics. There isn't one single, universally accepted way to fix this. Instead, surgeons tend to follow one of two competing philosophies. So on one side, you've got this single implant philosophy. The whole idea here is to use one long, clever device, usually a special kind of rod or nail, to fix both breaks in one go. You can think of it like a Swiss Army knife for bones. Then, on the other side, you have the dual implant philosophy. This approach treats each fracture as its own separate problem. So they might use screws for the hip break and a plate for the shaft break. Kind of like using a dedicated wrench for one job and a screwdriver for another. And you can really see the difference plain as day right here. On the left, that's the single implant approach. See that one long metal rod running down the center of the bone, with those screws at the top holding the hip fracture in place? Now look at the right. That's the dual implant strategy. You can see how those three big screws are fixing the hip break all by themselves, totally independent of the rod that's stabilizing the main shaft. Two very, very different ways to solve the same problem. So if you've got two different schools of thought, the next obvious question is, right? Which one is better? Which method gives the patient the best shot at healing up with no complications? Well, to answer that, we have to turn to the data. What's so interesting here is that there's no clear winner. Just look at this data from a major review. The single implant seems absolutely perfect for the shaft fracture, a 0% failure to heal rate, what doctors call non-union. But it's a bit riskier for that delicate neck fracture. And the dual implant? It's the complete opposite. It's safer for the neck, but carries a slightly higher risk for the shaft. Oh, and on top of all that, the dual implant surgery takes, on average, over 40 minutes longer. It's a classic medical trade-off. And, while these numbers are great for seeing the big picture, they don't really capture what it's like for an individual patient when things go sideways. Because with a fracture this complicated, even with the absolute best approach, the biology of healing can be, well, unpredictable. So let's follow a real-world case to see what that means. The surgeons here decided to go with a single implant approach. And you can see on this x-ray right after the operation, everything looks pretty good. The hardware is in place, the bone looks aligned, and the hope is that things will start healing. But then, look what happens 8 months down the road. This is exactly the kind of risk we were just talking about. The neck part healed up fine, but the main shaft fracture has completely failed to join back together. You can see that clear gap in the bone. That's a non-union, and for the patient, this means another huge surgery and a massive setback in their recovery. in this case really highlights a challenge that researchers have been pointing to for a while. A study way back in 2009 noted that trying to perfectly line up two separate fractures with one single rigid device can be a technical nightmare. It often leads to a compromise where one or maybe even both of the fractures isn't put back perfectly, and that just increases the risk of problems later on. So, if both methods have pros and cons, how does a surgeon decide what to do for the actual patient lying in front of them? Well, it turns out they need a logical framework, a way to find a clear path through all this chaos. Newer research is proposing just that, a decision-making algorithm. And it goes something like this. Step 1, priority number 1, is always to deal with the femoral neck fracture first. It has this really fragile blood supply, and protecting it is everything. Step 2, you carefully assess the shaft fracture. Where is it exactly? What kind of break is it? And only then, after you've done all that, do you move to step 3. You choose your weapon, basing the decision on that specific combination of injuries. So here's the crucial point, the main takeaway from all this. It's not about single implants are better or dual implants are better. It's about tailoring the fix to the unique anatomy of that specific injury. For some fracture patterns, a single nail might be the perfect, elegant solution. But for others, maybe when the shaft fracture is really low down on the femur, a dual implant strategy might be the only way to get both breaks stable. So where does all this leave us? Well, what's pretty remarkable is that after decades of surgery and research, the debate over the single best way to fix this injury is, well, it's still unresolved. So let's just recap the key takeaways here. First, both single and dual implants can work incredibly well when they're used in the right situation. Second, the surgeon's skill is probably more important than the specific piece of metal they choose. Third, because this injury is so rare, it's really hard to do the kind of big scientific studies that would give us a definitive answer. And that all leads to the final point. The surgeon's choice has to be based on the injury in front of them, not on some universal rule. And honestly, this quote from that big 2019 review just hits the nail on the head. A paucity of randomized studies, which basically means a lack of top-tier evidence, limits the ability to recommend one approach over the other. The medical community just doesn't have the knockout data to declare a winner. So if there's no single best answer for an injury this severe, what does that really mean? Maybe it means the future of surgery isn't about finding that one perfect one-size-fits-all implant. Maybe it's about getting better at diagnosis and about giving surgeons a whole toolbox full of amazing options so they can build a truly custom-made solution for every single patient every single time.